Hey everyone, this is Mr. Oliveris, and this is going to be one of the math department's first review videos. I don't have a lot of time, but this is for the Unit 2 unit test. I won't be able to go through everything, but I'm going to try to go through as much as I can, so just stick with me. If I'm going too fast, just pause it and rewind and see what you need to do. Okay, so our first section is about function notation. So this is our function notation, f of x equals negative 4x plus 5. So when we look at these problems, we're either substituting x in, or we have the function equal to something and we're solving for what x is. So when we have this one, find f of x when x is negative 2, it's very simple. That means x equals negative 2, so in our function, we would have something like this. F of negative 2, sorry about that, equals negative 4 times negative 2 plus 5. All I'm doing is putting negative 2 in there, so you get negative 4 times negative 2, which is 8, plus 5, which is 13. And that's it. That's your answer. So when we say find f of 4, that means substitute 4 in for x. So we get negative 4 times 4, what we're substituting in, plus 5, which equals negative 16 plus 5. Use your calculator if you're afraid, but this is going to be negative 11. Now ones like this, we actually have f of x equals negative 15. Well, f of x up here equals this, and if it also equals this, negative 15, then we can set these two equal to each other. So we say negative 15 equals f of x equals this, it also equals this, negative 4x plus 5. Then start solving for x. Minus 5, minus 5, you get minus 20 equals negative 4x. And then this is negative 4 times x, so you divide by negative 4. So negative divided by negative is a positive. 20 divided by 4 is 5, which equals, these simplify, x. So x equals 5. This will be the same thing if it's 37, but we're going to hop over that one just for the sake of time right now. Okay? Now, it doesn't change if it's a fraction. So again, if you need to go, if this is going too fast, just pause it and go back. But I'm going to erase some of this. Okay. So let's look. Given a fraction, let's try this one. Actually, let's try this first one right here. Okay, when x is equal to 2, so we just do this: 2 times negative 2 plus 3 over 6. 2 times negative 2 is negative 4 plus 3 over 6 equals negative 1, 6. And that's all there is to it. Now ones like this, alright, when you have this fraction, don't freak out. Okay, I'm going to do this problem right here over here. So this means f of x equals 5/2. Well, this is f of x. It's not written there, but it's implied. Well, if this is our function, and this, we know it's going to equal this, f of x equals this here, f of x equals this here, we can set these two things equal to each other. So we say 2x plus 3 over 6 equals 5/2. Now you might be afraid because you're thinking, oh gosh, it's a fraction. But just go through your steps here to solve for x and let's see what happens. Okay, so we want to get rid of 6 in the denominator, so we multiply by 6. That simplifies. Now watch, there's a couple ways you can do this. I'm going to do some side work up here. 5/2 times 6 will equal, since this is a whole number right there, 5 times 6 gives you 30. Keep 2 underneath, and then this is read as 30 divided by 2 is 15. Sorry about that. Okay, so then we have 2x plus 3 equals 15. Subtract 3. 2x equals 12. Divide by 2. X equals 6. Okay? And that's it for those. Just go through, be patient, be calm, and go through and you can solve it. Okay? Okay, looking at our next section, this is pretty basic. Let's go through it real quick. All right, we're looking at function notation still. We're trying to draw stuff from a table and a graph. So looking at this one, what is the value of f of 1? All right, that means when x is 1, well, let's see. When x is 1, oh, it's going to be 7. That's all it is. Fill in the blank. F of what equals 11, so we don't know x. We don't know what it is, so we say, all right, well, we know this is 11. So when x is 3, we know we're going to get 11 back. So x here equals 3. And then what's f of 4? Here's 4. You get 13. Easy. You're all going to do great. It's going to be no problem. All right. Use the graph f of x to answer the following. F is 0. All right, so we go, all right, x is 0. X is 0 right here. And then we want to see what's our y value when x is 0. So we go, crawl up here. Oh, there it is right there. Y is 2. So when you get 0, your y value is 2. Now these are different. We don't know our x values. Find x. That means we don't know the x value. So find x so that f of x equals 0. That means y equals 0. So what is when y is 0? All right. When y is 0, what are our x values? All right, well, here's y at 0. What are our x values when y is 0? Crawl over on the x-axis then. Oh, there's one right there, 1. But there's another one over here. If we crawl over here, 2. So when y is 0, you're going to have 2 x values. Right there, right there. Find x so that f of x equals 4. Okay, well then our y value at 4 is right here. So what are our x values going to be? Well, let's see. Crawl over here. There's 1. That corresponds with 2, positive 2. When y is 4, x is 2. Right, that's the 0.24. That's what that means. So this is 2. And then we have 1 right here, don't we? Right? That corresponds with negative 1. When x is negative 1, y is 4. Or when y is 4, x is negative 1 also. Okay? Alright, let's keep going. Okay, be careful here. Just you gotta make sure you know what independent and dependent variable is. Alright? And how to set up your equations. So you have an expense account with the cafeteria. It has $20 in it, and you take out $2.65 per day. I'm going to see that per day. I'm going to go ahead and write $2.65 per day, D for day. All right, so let's look. Write an equation. Well, we know that this, let's say the account will equal $20. We're taking out, so this is minus, we're subtracting how much? $2.65 a day. There it is, okay, a day. So I actually like to answer what the dependent variable is here. So our account is dependent on how many days have passed, because when the days pass, our account gets smaller and smaller and smaller. Okay, so our dependent variable is the A, and it represents our account. The independent variable is the number of days, because we can change the number of days. So our independent variable is D, right? And it represents the number of days passed. Okay? What's f of 6? We just did that previously in function notation, so we just do 20 minus 2.65 times 6. And you can put that in your calculator and solve that out. And what does that represent? That represents the account after 6 days. So after 6 days, you're going to have so much money left. And I believe this is going to be $4.10. Sorry for that right there. So after 6 days, you're only going to have $4.10 left. Now this one, if you have $9.40 in the account, how many days have you been eating lunch? Okay, well, I'm sorry if this is in the way right there. I don't mean for it to be. How many days have you been eating lunch? Well, you just substitute. Okay, that means we have the account. We only have $9.40 in the account, equal to 20 minus 2.65 days. Go through your algebra. All right, D's over here. We want to solve for D, so subtract 20 first. Okay, so 940 minus 20 would be $10.60, actually negative, equals minus, bring down your minus sign, pay close attention to your signs. Okay, divide by negative 2.65, divide by negative 2.65, and what you'll end up getting is D equals 4. 4 days have passed in order for the account to get that low. Okay, so D equals 4. Okay. Guys, be careful with your graphing. Remember, you have to solve for y here. So you need to subtract 3x from both sides. You come out with negative 4y equals minus 3x plus 8. And then you're going to have to divide everything by negative 4. Well, when that happens, you have a negative. This is the thing that kills us, is not paying attention to our signs. Negative divided by negative is a positive 3/4 x. 8 divided by 4, negative 4, is negative 2. This is your y-intercept. So come over here down to negative 2. Oh gosh, sorry. I don't know what's happening. Hang on one second. Let me erase that. Okay, let's see. Alright, come down to negative 2. And then our slope is 3/4, so we're going to go up 1, 2, 3, and to the right 4. 1, 2, 3, 4. And that is how you graph that if you can draw a straight line, unlike me. Okay, but that's all there is to it. Okay. Pay close attention to your signs on these. Okay, guys, we're looking at discrete or continuous functions now, real world scenarios and appropriate domain and range. So let's take a look at this one right here. Zach details cars. He charges $20 per car. I'm going to remember that. $20 per car. $20 times C. He can detail 6 cars a day. The amount of money he makes in a day is a function of how many cars he details that day. Okay, making our equation, we basically already made it. It's just going to be 20C, right? Or we could say how much money M equals $20 times the number of cars. Well, let's think about our domain. If we were to look at this, we're going to change the number of cars because this function money is based on how many cars he details in a day. So your domain is what you're substituting in, your input. Alright, so our cars will change, so our domain is the number of cars. And he said he would only do 6 a day, so he can either do 0 or 6. Now our range, and I apologize for this little arrow here, but our range, okay, if he didn't do a single car, he would make $0, right? Well, our range will be the money, sorry, he makes. And if he didn't do a single car, he would make $0. And the most he could make, if he did 6, 20 times 6 would be 120. Alright, this one's going to end here, but I'm going to make a part 2 and continue watching that one if you need help with the rest of the problems, and we'll go from there. But just look at this, work hard, and you'll be fine.